Well, welcome everybody to today's FDTD GOES Applications webinar. Today we're pleased to have Paul Schlatter from the Boulder, Colorado WFO, and he's going to discuss hail swaths in the snow and ice channel. So go ahead to the next slide. And as we advance to the next slide, we'll just get a few logistics out of the way. First of all, these sessions are recorded, and if you'd like to see the recorded, if any of your staff missed this and they'd like to see the recording of it, it's available on the page that you see here. And also, we're looking for speakers. We're looking for volunteers. If you come across an interesting case from GOES 16, let us know. Our emails are listed down there at the bottom. I'm Dan Bikus, and Scott Lindstrom is also another point of contact. Go ahead to the next slide. And just a few logistics. We're going to have about 20 minutes or less for the speaker. And you can send questions via the GoTo chat, or you can just wait until after Paul is done talking, and we'll have plenty of time for questions and discussions at the end. And then very importantly, do not press the hold. So at this time, I'll turn it over to Paul.
All right, thanks. So I'm presenting this just kind of by accident. This is one of the things where I was just kind of looking around at satellite data, then noticed something out of the ordinary when I was looking for something else, and then it kind of snowballed into, hey, this is really cool. You know, not sure of operational usage yet, but at a minimum, I hope as I go through all this, all you will say, hey, that is pretty cool. Didn't necessarily think about that, or didn't really know that could be something that could be used. So how this all started is several weeks ago, April 27th, we had a really cold pool aloft. It was about minus 22, minus 23 at 500. It was close to minus 10 at 700. And we had really very weak steering flow across northeast Colorado, and so the storm motions were kind of a little bit all over the place, generally out of the west, but then propagation effects had some go towards the east, some that remained almost completely stationary, and I'll show that. Instability was pretty weak, but enough for hail production. It was around 400 to 800 joules per kilogram surface-based CAPE. Obviously, with the really cold air aloft, it had a low wet bulb zero level, and I'll show a sounding on that. And we were definitely thinking, given the low wet bulb zero height, slow storm motion, and just enough convection to generate hail that we weren't worried at all about severe threat. But we did feel that, given the low wet bulb zero height and that kind of thing, that hail reaching the ground was probably going to happen. And so that's what we went into for this particular event. So this is not a forecast, this is the RUC analysis at 18Z or noon local. And you'll see that across our area, it's kind of showing the same thing that I mentioned before. Anywhere between 500 to 700 CAPE existed right around noon on that day, and it was surface-based. The temperatures were in the low to mid-40s, and then actually closer to 50 across part of the Denver metro area and along I-25. So again, this is a cold or cool convective event with surface temps right around 50 once convection started going. And I'll show you on the sounding, the convective temperature was actually about 51, 52, and we got there, and that's when cells started popping up in various places. In the final analysis, just showing you that the main reason, given low instability, the bulk shear for supercells just wasn't there. So we were expecting slow-moving convective cells with really low wet bulb zero heights on this particular day. Not much shear. Better shear down south, but we were focused on northeast Colorado. I know the sounding is hard to see, but it shows a surface-based dry adiabatic layer, and then a nice, real thin CAPE profile and the really cold temperatures aloft. Notice the photograph again showing the weak steering flow. We're expecting much storm organization, just kind of weakly pulse up-down type storms that didn't move a whole lot. The flow aloft was really weak, especially in the convective cloud layer. It's 10 knots there, it's 20 knots right around there. So slow storm motions all around. And it does say I think it says wet bulb zero height, 2,300 feet. And the way we look at that is, given how cool it was at the surface and aloft, any hail core that gets generated probably wasn't going to melt a whole lot in that 2,000 feet, just as it just diabatically depresses the wet bulb zero height even further. And I'll show a little bit of radar imagery of that. So we were watching complexes of storms just kind of go up and then move very slowly and then dissipate after on the order of an hour to an hour and a half. I can show you that now that I've got GR up and running. I'll pull this over, showing right about the same time. Focus on the area here and the area near New Raymer where a storm's already going. But you'll see as I advance, the stuff near I-25 and the stuff near Raymer and New Raymer just kind of sits there for a good 30 to 45 minutes. Nothing impressive, right? Not too impressive. And there's some more storms down here as well. Let me pull this away. We'll get to satellite soon. Next. So this particular storm I don't have a radar loop of, but this was another, it's getting up to 60 dBz echoes. In this particular storm, you saw the other ones kind of moving a little bit towards the west, others that were moving towards the east. This storm actually just propagated. It formed here and slowly propagated south before dissipating, but it had some higher reflectivity and kind of sat over this area for a while. Finally, this one is in Goodland's area. It's still Colorado County, but Goodland covers this. This is from the Goodland radar. And since I like this is the strongest one of the day. I'll zoom in a little bit closer on that one. And then I'll pause so the screens catch up. Let's see a good time to look at. How about right there? If you notice that loop, it was drifting slowly to the east. There's some pretty high reflectivity in this particular area. And if we look at correlation coefficient, all high. This is how close to the ground. We are about 60 miles from Goodland's radar at 6,000 feet off the ground, so we expect it to be all ice anyway. And notice that ZDR is 0, so that's all small hail in that particular hail shaft. We knew it was smaller hail because correlation coefficient was so high. We also knew it wasn't just going to be grapple, that it was going to be the harder ice in that area because of how high the reflectivity is. You don't see grapple with reflectivity that high. So we thought it was all interesting. We didn't get any. So back to the operations of the day. We didn't get any big hail reports, and nor were we expecting them, but we did get an interesting report out of that storm near New Raymer. Let me back that out. Let me get to New Raymer. I think I show it later. I'll get to that later. But we got a report of a funnel cloud out of that storm near New Raymer that I showed. And then we also got several reports of, it was probably the same person reporting, two different people reporting the same report. That's how I'll put it. We got it two different channels. And they reported 12-inch hail accumulation. So okay, maybe that was possible. The storm moved really slow. We asked them for some pictures because we were just kind of curious. We have a really nice tower cam near New Raymer that looks, many miles over the plains. We couldn't see any white on the ground. We checked GOES 16 at the time. Problem was it was cloudy everywhere, so we weren't going to see any hail swaths, in near real time after the storm passed. Just wasn't going to happen with all the cloud cover. So that's when the next morning it cleared out in a hurry. The storm, the trough axis moved overhead overnight, cleared out. It was crystal clear almost everywhere. So I was like, you know what? It was cold enough. It was freezing all overnight. So any hail that fell that afternoon, given how cool the surface temperatures were, how cool the air was, probably still going to be around. So I was going to look in the New Raymer area to see if I saw any hail swaths in GOES 16. So the interesting thing is New Raymer is out in here. And even before the cloud cover was there, I couldn't see any hail swaths there. But I looped these images quite a bit. And sure enough, I started to see patches of white that kind of looked like snow, not as bright, but kind of looked like snow that just didn't even move. One there. That's the one in Morgan County, and then this one in Cheyenne's area. That's the one I zoomed in on with that I had that showed just recently. In visible, the channel 2, these didn't move at all. They were nice and bright and white. So I'm like, okay, that's probably going to be hail. So let's check out the snow ice band, channel 5. And sure enough, those little smudges in the same area, that arrow's a little off, it's actually right there, darker. And we would expect that in the snow ice channel. If it is ice, it should be a darker gray, and sure enough, it was. Just for the heck of it, I also went to the channel 7, the near IR, just to see, if there is ice or a hail swath covering the ground in those areas, the temperature should be a little less. You can't see it here, but when I used AWIP's cursor readout, anywhere between 3, 5, 7 degrees Celsius cooler than the surrounding temperatures, because by this time, the sun had been up for a couple hours, the ground was starting to warm, but those the hail swaths on the ground obviously would not warm up because they're ice covered. And this actually showed up using cursor readout in AWIPs. So pretty neat, very neat stuff. And here's an actual loop of the red visible showing that those patches just weren't really moving. And you can really see when it clears out. I know there's a little bit of cloud cover. New Raymer's right in this area. There just wasn't anything there. On the snow ice band, again, this shows in the loop, and I'll let it run a little bit, just that it's a darker shade because it's ice. And going to shortwave doesn't show a whole lot, just because, again, cursor readout was how I was best able to analyze it. It was a patch of colder temperatures on the surface there. Okay, so going back to New Raymer, showing this, so, we weren't sure what to think about the deep hail report, because one would think hail that deep would show up on satellite, given those other 3 areas from storms that were, maybe even a little bit weaker than the New Raymer storm, did show hail swaths there. So it's not likely that much hail could melt, given that all those other 3 storms were able to generate hail swaths that lasted till the next morning. So it's possible that the accumulating hail occurred on such a small scale that the satellite couldn't pick it up. That's one possibility. The other possibility is maybe it just didn't even really happen like they said it did. Never did get a picture, even though we asked for pictures from the area. That was an interesting thing we were looking at. And then split window difference. This is Dan. Is this something you wanted to talk about?
Yeah. You can just go on to the next slide, and I'll discuss it since I only have a few slides. This is from a case earlier in April, and this is just a still image of the .64 visible band showing snow cover over southern Colorado. And there was some melting during the day, but I'll ask Paul to advance to the next slide. And if I could remind somebody's not muting their phone. I hear some feedback on the phone. Just make sure your phone is muted, please. And we'll move on to the 1.6 micron band, and what we can see is a much different picture than what we saw in the visible band. In the visible band, it was pretty much uniform, that white.
How many other people are there?
But here in 1.6 microns, we see some differences. We see some regions that are that I've highlighted in those arrows that are just darker, and that's actually a mix of rain and snow. What happened was, in those areas that are not as dark, it was pretty much all snow. And then the regions it was darker, it was rain occurred after the snow. So you have slushier snow, and that's the signature that we're seeing here, very similar to what Paul was showing in the hail swaths. And again, it's slushier snow, and we have that water mixture, and we have larger ice particles, and some melting has occurred. So that's why it's showing up. I'll ask you, Paul, to go to the next slide.
I definitely don't know anything about
there was another blog post, if you want to read more into the why of why we see this signature. You can check out this blog post on your own time. It's interesting. It looks at a different case, but it has pretty much all the explanations on here. And then you can go to the last slide, Paul.
Reconvene at 1.
And Paul, you can take away. You read your takeaway points here.
Sure, yeah. So the thing I took away from it is that conditions were pretty unique for hail to survive that long on the ground. It was a very cold event in terms of, a convective event with surface temperatures 50, and then overnight it dropped into the 30s. Storms are moving really slow. So I think that was, it was unique in that the environmental conditions for, most other offices probably especially aren't going to happen in the warmer season, from now through September. Those conditions would be thought to be rare. But I think this shows that if it clears out at all behind a storm that passed, wherever you were looking, whatever event you're working, it'd be worth to look at to see if there is a hail swath there, because you notice these storms weren't all that strong, and yet the hail showed up really well when you looked at the visible plus the snow ice channel. Of course, at nighttime, I'm not sure how you could find the hail swath, so that's more of a daytime event. But I think this could help you figure out, okay, did hail fall in those areas? And pretty easy to detect. I was shocked that I found those 3 hail swaths. I was only really looking for near New Raymer, and I found 3 others. So really neat case, and hopefully may provide some operational benefit in terms of if it can clear out after a storm passes. So that's all I had. Dan, is it time for questions?
Yeah, questions or comments for Paul?
Well, I'll break the ice, so to speak. FRS Towing.
Yep, go ahead, Tony.
Yeah, and I don't know if you can go back to the loop of, where you were looking at it, trying to find, you could see it, in those 3 other areas, but not up there by Raymer. It may be, it's subtle, but I think maybe it just never really cleared up enough, because there are some low clouds hanging around there. So that was my only other guess for why, because it certainly looked convincing enough from the other signatures that there should have been some hail there. And where did you get the report that someone claimed there might have been 12 inches?
It was the fire department. So NAWAS called saying fire department, and then a storm spotter called giving the exact same report.
Oh, and was that in Raymer area?
It was in the Raymer area, yeah.
Well, that would be my thing, is that it probably, there's some still fuzziness there in the viz, in this viz, and they might even try to look a little later in the day. If it got a totally clear look, might still be a hint of it, but that would be my best guess for why you're not seeing it.
Yeah, it's definitely possible.
Okay, great job, thanks.
Any other questions for Paul?
Hi, this is Dave in Buffalo.
Hey, Dave.
Hey. I was looking at that storm over the north. Hold on. There we go. I was looking at that storm over the northwest, and you can see the shadow sort of half covering it. Is it possible the shadowing from the more extensive cloud cover in Raymer is making it harder to see?
Yeah, it's certainly a possibility. The clouds, in my opinion, the clouds certainly look a lot less thick here than in this part of Weld County. But it's certainly possible. You can see a shadow here right at the end of the loop, but Raymer's more in this area. But it's possible. Yeah, I would be interested to look later in the day if it cleared out at all. Because given how slow that storm was, and if there really was 12 inches, that hail should still be there, because it was chilly on this particular day as well.
Okay, any more questions?
Hi, Paul. This is Greg Patrick in Southern Region. What kind of lightning, if any, did you have with these cells?
Just a handful of strikes per cell. Those ones, and I'm pretty sure this one may not have even had any lightning. This one definitely had lightning. The strongest one of the day that went into Goodlands area definitely had lightning. But the flash rates were nothing spectacular. Like I said, maybe 4 to 5 strikes during its lifetime.
Okay, interesting. Thank you.
Okay, any more questions for Paul?
Yeah, I guess it's back to Tony again. Yeah, Paul, I know you've looked at it. I know Brian Mata in our division has been working a case with I guess it's a student up there in the office talking about plowable hail. Do you have any reference information that you could provide later? Because I know these events are pretty rare, but actually do happen, and I don't know how in other parts of the country, but along the Front Range here, that's been an ongoing study and I don't know if Brian's on the line, could fill us in a little bit on that study, but now that you have these satellite images, it'll be pretty interesting to try to document more of these.
Yeah, I can talk about it as well. It is an interesting project. I can send a reference that's already been written, and we are in the process of submitting to BAMS. The idea was accepted to BAMS. Now our research partners at Colorado are writing the paper, and we've already provided input. In a nutshell, though, we are looking for it's a radar infused algorithm that can. The intent is to detect storms capable of generating hail that could accumulate several inches deep. And then, in theory, we could let our partners in the transportation department, like CDOT, Colorado Department of Transportation, know when those storms passed over an area. They might be able to deploy some plows. The science is there. Not sure about the algorithm yet, but we are definitely excited about GOES 16 being able to detect these, where the hail is accumulated, assuming it clears out afterwards. I mean, just in this event alone, it was, even though it wasn't we weren't really getting our hopes up much, but it showed really clearly where hail had stuck on the ground.
And in reference to there not being there rare, we had a little bit of an event on Monday right here in the metro region, correct?
Correct. Yeah, and there was lots of accumulating hail in Denver on that one, especially on the west side of the metro. And that wasn't your garden variety little pea-sized hail. A lot of that was golf ball to baseball size accumulating in parts of Denver. And I haven't checked the satellite yet from that event, but I'd be curious to see if that lasted till the next day as well. It probably did, but I'm not sure it cleared out enough to see it.
Right. All right, thanks a lot.
Any more questions for Paul? Okay, well, just a final reminder, if you're interested in leading one of these discussions, you come across an interesting application of GOES 16, just let us know, and you can lead one of these in the future. We're trying to do these on a regular basis, so the next webinar will be 2 weeks from today, May 24th.
Hey Scott, can I interrupt you a second?
Yeah.
This is Kevin at Birmingham. I wanted to add a question theoretical for Paul. Paul, at times we've seen, with some of these larger tornadoes, we've seen that scarring, even from the GOES East or 13 now. With the higher res, do you think that's going to be possible in the future to see some of those larger tornado tracks, and with the same kind of theory that you're working here?
I would definitely assume so. Scott, you want to take
I mean, there have been cases where GOES 13 can see tornado scars. There's a really famous one up in Menominee County, Wisconsin, and I know the ones from the outbreak in 2011 in Alabama. You could see the scars on the visible image with the old 1 kilometer resolution, and now that we have half kilometer and the red visible, it's going to show up really nicely when you have something strong.
Yeah, that's what I was kind of wondering if we could even see some of the smaller tracks now with the half kilometer. I don't know if we put that theory to the test yet, but I know some of the polar orbiting ones could see it, but some of that res is like 250, but I still thought we may be able to test that out coming up. If we have any outbreaks.
Yeah, that's a good idea to look for something to look at day after now. Yeah.
This is Dan Lindsay. I actually found an example from those tornadoes that were southeast of Dallas a couple weeks ago. You could see some of the damage paths in was it Van Zant County. I can send that along if you'd like.
Was that an EF3, Dan? I can't remember.
There were multiple tornadoes in that day, and at least one of them was an EF3. I'm not sure about the other ones. And there were multiple paths that you could see. Right. It's very subtle, but you could see it if you stretch the color table appropriately.
Yeah, I think that'd be the key. Well, and just to be fair about it too, and the outbreaks from 2011, the entire swath of that damage, those damage paths were like F4 and F5 damage. Some of that was, more 2 and 3, and you could still see it pretty well from GOES 13, but you just had to know where to look. That was
Right,
sort of the
right.
key.
Yeah, once you know where to look, the eye can kind of really bring out the detail.
Yeah, let's explore that some more as we get into peak severe weather season out in the plains, maybe.
Yeah, it sounds like a great topic for a future webinar like this if we come across another interesting case. Any other discussion points or questions? Okay, thanks everybody. Next webinar, May 24th at 18Z, and have a great day.